All right, so I'll give you, 3, 4 minutes to write that down. Those are vocabulary words that are going to be used predominantly in every single story problem we see. We'll see 4 of those, 3, mostly 3 of those vocabulary words in every single story problem we do. So it's going to be important to be able to know what they are and how to transfer that vocabulary into a picture. Okay, so the horizontal, okay, we're going to view that as, if I'm out in the country and there's no woods or anything like that, no crops, I look out to the line that separates the earth and the sky, right? That's our horizon. Anything that is parallel to that is referred to as a horizontal, okay? It's essentially the line that goes perfectly east to west, okay? That's what we're going to view them as when we draw them on our story problems, okay? A line of sight, it's an imaginary line that goes from your eyeballs, okay, or the observer's eyeballs, to whatever's being looked at, okay, whatever's being sighted in by the observer, okay? An angle of elevation is the angle that is then created by those two things, the horizontal and a line of sight, when looking up at something, when looking above the horizon at an object. Elevation means to move up, right? So angle of elevation is with the horizontal and the line of sight when looking up at an object, okay? An angle of depression is the same thing, but now depression means going down, right? Okay. So angle of depression will be made with a horizontal in the line of sight when looking down at an object, okay? And that last one is one that you might see every once in a while, and actually a lot of times it gets misused or doesn't get used when it should be used, and it's called an angle of inclination. And the root word inclination is incline, right? It's essentially the angle that's created when your line of sight follows an incline or follows an already defined object. Kind of like if I was laying down in front of the overpass when it starts to, increase, when it starts to elevate, and I look straight up that road, my eyes would be traveling a line of sight. That is the road, which is the overpass, which is an incline. Does that make sense? If I'm laying at the base of the hill and my eyes travel up that hill, or the base of the reservoir, and my eyes travel up the reservoir, the side of the reservoir, okay? Because it's already a predefined object, we usually call it an angle of inclination, okay? There's actually a question here today that I think, personally, they should use the word angle of inclination, but they use angle of elevation instead. Ultimately, what happens is a lot of authors will interchange those inappropriately, but we treat them the same way, so it's really not a big deal. But if you do see that word inclination, you treat it just like you would angle of elevation, all right, mathematically. These words are going to be used inside our story problems. And so this is a diagram, just a general diagram of where these objects, its terminology, exist, okay? Every scenario that we use is going to be somewhat symbolic to this, or represent this, or resemble this in some fashion. We've got somebody maybe in a car, being the observer, and they're looking at the top of this building, the top of maybe the TV antenna on top of that building, okay? So that red imaginary line is the line of sight, okay? A lot of times I make it dotted because it doesn't really exist. Does that make sense? It's not a physical line, okay? But it is what connects my eyes to whatever I'm looking at, okay? The horizontal, okay, that bottom horizontal obviously is the road, correct? Okay, which is going to be a kind of a constant in a lot of the problems we do. Okay, either the road or a lot of these questions are kind of based in the ocean, so the sea would be the horizontal. And then we've got the building. The building is ultimately, we're going to say, perpendicular to the horizontal. So there is a right angle right here where my cursor is, okay? So do we see the right triangle? Okay. Now, the angle that's created from that horizontal and the line of sight when I'm looking up at the top of the building, that's the angle of elevation, okay? So this here is our angle of elevation. And my hopes are that you guys see this right triangle, okay? And if we have some information in that right triangle. Maybe we know some angles, or maybe we know some distances. We can ultimately use SOHCAHTOA to find remaining distances and remaining angles. Okay. If we reverse roles, if we put somebody on the top of the TV antenna and they're looking at the car, is that going to be the same line of sight? Yeah. Okay. So if you're standing right here and you're looking down at the car, your line of sight is going to be the same as that red dotted line. Okay. Now, this is where we've got to talk about how it's a little bit different. Our angle of depression, by definition, an angle of depression, if the object being observed is below the horizontal, then the angle between the line of sight and the horizontal is called the angle of depression. So what we need is another horizontal, okay? Because if I don't have that black line in there, okay, my angle of depression doesn't really exist. Does that make sense? Okay? So we need to put that horizontal in, passing through the observer's eyeballs, parallel to the horizon. Every horizontal we create is parallel to the horizon. And now we see where the angle of depression should be located. Okay? And think about this. If you're a person standing on that building and you look straight out, okay, so don't move your eyes up or down at all. You look straight out, your eyes should be following that horizontal. Does that make sense? Okay? And then when you start tilting your head to look down, that angle of depression is associated with the angle tilt of your head going down. Does that make sense? And that's why we call it an angle of depression. What do you notice about the angle of depression and the angle of elevation? What did I say that those two horizontals were one of? They're parallel, so the angle of elevation and angle of depression are alternate interior angles, so their relationship is that they are equal. They're congruent to one another. Okay. A lot of the questions that we deal with, guys, we're going to have that triangle right there, triangle number 1. Okay. But we can actually do this. Create a line there that's parallel to the line here created by the building, and have triangle number 2. And what do you think you know about triangle number 1 compared to triangle number 2? They're congruent. Okay. So if I want to find the height of a building, I could do that in triangle 1, and it's going to be, you know, that height is going to directly be right here. Okay. But I could also find this right here, and that is going to be the same as the height of the building, right? Does that make sense, everybody? So I can create this is ultimately a rectangle, right? Okay. Parallelogram, so that side there, same as that one. Okay. This top distance between the car and the building would be the same distance as down here at the bottom, the car and the building. So every once in a while, you might see me do a problem where we create maybe that top triangle, and I think, I don't like that top triangle, I'm going to deal with the bottom one, or vice versa. And you can do that. There's nothing wrong with that. Okay? All right, so every question that we come across is going to be like that. What I want you guys to know quickly, and we'll talk about this, we'll discuss this briefly, is that, you know, just like any other story problem in mathematics, sometimes they might seem a little far-fetched. Somebody's actually doing these. You know, I think we talked a couple of weeks ago about, like, you know, Sally rakes the yard in 3 hours, John rakes the yard in an hour and a half. Sally starts at noon, John comes in at 12:24, and then Sally takes a break, and then John takes a break a half hour later. How long does it take for them to finish raking the yard? And those are kind of very complex questions, right? And we've seen those. Are those really something people are going to do? Probably not. You could, but probably not. Okay. You're going to see some of that kind of play out here with these story problems. They're trying to get you to recognize that there are applications of this stuff. There is technology that we use on a regular basis that does this stuff. That's programmed to determine these things for us. You know, your GPS on your phone and that kind of stuff uses this math in it. Okay? But I want you to understand that when we read this scenario and it says we sight an airplane at an angle of elevation of 32 degrees, how do we know that? Well, there are tools that will find angles for us, okay? They got weird names, theodolite and diopter, inclinometer, clinometer, and there's a sextant as well. Those are all tools that will develop angles for you, okay, and read off an angle to you as you observe something. All of those have eyepieces on them, right? Okay, so I can look through them. There's some type of measuring device that's going to give me an angle back, okay? And they're going to be accurate. So there's and I'm not going to get through the physics with you of how they work, but they work. And you can go buy one of them. You go to Lowe's and Menards, you can buy one of those, okay? If you guys ever see surveyors out on the side of the road, okay, they're using those types of things to calculate distances and slopes and stuff like that, because they're taking measurements so they can do construction. An inclinometer or clinometer, those are actually something that you could make pretty easily, okay, if you have a protractor, okay, and all those things. All of these things have a protractor essentially on them. Now this one is more of a digital one, this yellow one, but you can kind of see here this circular thing, right? Okay, well that's a protractor. Up here, there's going to be a circular thing, okay? Well, there's readings and measurements on them, okay? Here you see a circular part, right? Here you see your circular part, okay? So there's the integration of essentially a protractor and all those devices. So we can make one of these pretty easily with a protractor, a weight, a string, and a straw, okay? And basically what you do is you attach it like that. Now that weight, physics is going to say that weight is always going to be perpendicular to the ground, right? No matter how I move my protractor. I'm going to look through that straw at whatever I'm looking at. That straw is going to define my line of sight. And then that string is going to pass through an angle, right? Does that make sense? On my protractor. That angle will then help me determine, I do a little bit of work, and the work is explained there. But that angle then will tell me my angle of elevation or my angle of depression. So you could spend a couple $100 on one of these, or you can make one with like $1.98. Okay. Now that one's not going to be as accurate as these, right? Okay. But for our purposes, it would probably be enough. It would probably work pretty accurately. Okay. All right. So get to some examples here, but hopefully I've opened your eyes to say, okay, this stuff can be done. Okay. I was actually, I teach a class out at Rhodes. Every once, I don't have it right now, but every once in a while I teach a class out there. And I had students that came to me, they were in a trig class, and I had them previously, the semester before, and they said, my trig teacher right now is making us determine how tall Galvin Hall is, and we don't have any instruments to do that, okay? They had tape measures, but he told them that they could not climb Galvin Hall. They could not get on top of it, okay? So they had to figure out how to do this. And they needed some type of instrument to tell them the angle, because they wanted to use something. We wanted to do one of these types of questions, okay? So it is feasible that maybe in some time you guys get in a trig class that maybe you have to physically actually do something like this, okay? I'll walk through these questions. Basically what happens when we write these problems down, we're going to construct a very simple SOHCAHTOA question from what we've seen maybe in Math Excel or what we saw on the worksheet earlier, something that's going to be very easy for us to solve. But the hard part is deciphering the story problem into a picture. I like to take them sentence by sentence. It says an observer on the first floor of an airport control tower sights an airplane at an angle of elevation of 32 degrees. Okay, it tells me a couple things here. Angle of elevation tells me the airplane is where? It's in the air, right? Okay, it's above ground. Okay, so it's not parked on the runway or anything like that. So I've got my control tower down here. Okay, and I'm going to have my airplane. And your pictures, guys, they don't even have to be pictures, but we've got our airplane up there. Okay, somebody is in the control tower looking at that airplane. So if I look at that airplane, what terminology, what vocabulary word did we say that red line is going to represent? That's your line of sight. Okay. What is this black line here? We're horizontal. Okay. Now, I didn't draw it very straight, but I don't want all these bumps and hills and stuff. But it says the angle of elevation is 32 degrees. By definition, the angle of elevation is the angle created by the horizontal in the line of sight if you're looking at an object that is above the observer, right? So does that make sense that that angle right there is your angle of elevation? 32 degrees. Okay.
Sometimes I kind of explain it as if I'm a person and I'm laying down right here. Okay, that's my stick figure person. And I'm looking straight along the ground. The angle of elevation is how much I need to tilt my head back so that my eyes will meet the airplane. Does that make sense? Okay. So that's something you can think about if you struggle with finding that angle. Says the pilot reports the plane's altitude is 3.5 kilometers. Okay. First thing we need to know what altitude means. And we've talked about this a lot in this class. But altitude, not only is it the height that the plane is off the ground, because there's a lot of different heights that we could use. It's the shortest height, right? Does that make sense? Okay. When we talk about your height as a person, we say somebody's 6'1" because that's the shortest from their head to the ground, right? Okay. But I can go from the top of my head over to the base of the wall over there in front of my smartboard and say that I'm 22 feet tall. Well, that doesn't make any sense, does it? Okay. Because tomorrow I could say, well, now I'm going from my head to the other wall. Now I'm only 13 feet tall. Okay. So we always use the shortest distance because that's going to be constant. Okay. So the shortest distance, and it's going back to a very, very simple postulate we talked about, that from a point to a line, the shortest distance is using perpendicular lines, right? And that's the altitude. Okay? And they say it's 3.5 kilometers. Okay? Now, the next part of this says, is where we're actually getting into the question. It says, what is the plane's horizontal ground distance from the tower? And what that means is if there is a person right there, directly underneath the airplane, how far do they need to walk to get to the tower? So that's the horizontal ground distance. Is that okay with everybody? Okay. I'm going to call that X. Hopefully you see it. I'm just going to kind of eliminate the graphics of this. Hopefully you see it. This is just a simple SOHCAHTOA question, isn't it? But you got to be able to fit the parts, fit the components into a picture. Okay. What would you use here to solve for X? Tangent. This is the opposite side, and this is the adjacent side. So we would say tangent of 32 is equal to 3.5 over X. We've seen the algebra already. What's going to happen with that object and that object? They're just going to replace each other, right? They're going to switch spots. So we get 3.5 divided by tangent of 32. Make sure you're in degrees on your calculator, and you should be able to determine how far that is then. Okay? This question is changed entirely if we take out one word. If I take that word out, and it says, what is the plane's they said take two words out. Okay, sometimes you'll just hear them say ground distance. The plane's ground distance from the tower. But here it says horizontal ground distance. If I take those two words out, it says what is the plane's distance from the tower. Now what would you be looking for? You'd be looking for the line of sight, essentially, right? The direct path from the airplane to the tower. Okay, you look for that red hypotenuse. Okay. Usually your line, I don't want to say usually, I think it's all the time, but your line of sight is going to be the hypotenuse. Okay, all the way to right triangle. Is that something we can do? Okay. So all your questions are going to be some version of that. Okay. So we get this. Okay. Helicopter pilot sights a life raft. Where's the helicopter? Probably in the air. Where's the life raft? Probably in the water. In the water. Okay. So that's kind of the situation we've got going on here. Okay. So there's my water. Here's my helicopter. Okay. And I'm going to put my life raft down here. Okay. So the angle of depression is 26 degrees, and the helicopter's altitude is 3 kilometers. I'm comfortable with that altitude first, drawing that in. Does that make sense? Not what I wanted to do, but all right. So there's 3 kilometers. Okay. What would you call that line right there? That's your line of sight. Okay. Now they give me angle of depression is 26 degrees. If I'm in the helicopter and I'm looking straight out, that is my horizontal. And I need that because of how we define what an angle of depression is. An angle of depression is always made from your line of sight, which would be from H to LR, and a horizontal. Okay? Well, H to LR needs to get a horizontal, we need to implant one. We need to superimpose a horizontal over top of this. Okay? And now the angle of depression is that angle right there. And if you think physically about it, put yourself in the helicopter. If you're looking straight out, and then you tilt your head 26 degrees, you've tilt your head down 26 degrees, so you've depressed your angle by 26 degrees, and you would be able to see the light raft. Does that make sense? Okay. So ultimately, what we do to find an angle of depression is that horizontal being kind of the side of an angle, and it's going to rotate down to become your line of sight. So that's 26 degrees. Now, we have essentially two triangles here, right? And I know stuff about this top triangle. I don't like dealing with that top triangle. I like dealing with this bottom triangle. I put myself in a situation of I'm in the life raft, and I'm looking up at the helicopter. What should be my angle of elevation if I'm in the life raft? 26 degrees. It's that alternate interior angle aspect that allows us to transfer that value, right? Okay. So that's what I'm going to look at. Now, so I would have that right triangle. Is that okay with everybody? And again, it wants the ground distance, so it wants that for my answer. If you're a person that prefers to look at that triangle right there, because you know that was 26 degrees, in order to find my ground distance, wouldn't it be that distance up top here? And what would this distance here be? It'd be 3. So you got that rectangle, right? And that's all I'm using is rectangle parallelogram properties to kind of transfer values. But you can use triangle 1 or you can use triangle 2. I like triangle 2. That's what I prefer. Okay? So pretty much every time that we do one of these problems, I'm going to transfer things to that triangle. So does that kind of simplify things down to 26? That's 3. I'm looking for x. What trig ratio would I use again? Tangent. So tangent of 26 is equal to 3 over x. And we get that. Something we can do? All right. A lot of these early on, for some reason, deal with tangent, but you can still use sine and cosine depending on what they give you. This question, and we won't get through all of this question or do all this question just because of for the sake of time. But we've got a monument here. We've got an angle of elevation to the sun. The sun casts rays, and those rays get blocked out by an object, and that creates a shadow, right? If I put my sun over here, my shadow is going to exist over here, correct? And if I put my sun over here, my shadow is going to exist over here, right? Doesn't matter where you put your sun. Either side is fine. I'm just going to let's leave it over there. My shadow would be there, right? And they're saying in this question, my shadow is 215 feet. The goal is to find out how tall the monument is. So that's H. Now, the question gets into talking about the angle of elevation to the sun. Okay, when the angle of elevation of the sun is 52 degrees. What that means to us, if you were to put your head right here, laying on your stomach, and your eyes are following straight across the horizontal, right across the horizon. Now you need, and your face, your tip of your nose is on the shadow, tip of the shadow. The angle of elevation to the sun is when you lift your head to sight straight over the top of the monument directly into the sun. That there is your angle of elevation. So that'd be 52. Is that okay with everybody? Okay. This is opposite again. This is adjacent, so you'd probably use tangent on that one, correct? Okay. So some of these are just going to kind of walk you through the vocabulary or the terminology that they use to develop the question. Okay, you know what a guy wire is. Okay, a lot of people just vocabulary-wise think it's actually that. It is not a guide wire; it's a guy wire, G-U-Y. And you guys know what these are. They're on telephone poles at the end of a link of or a row of telephone poles. So if I have these telephone poles, okay, there's a lot of stress and tension on the right-hand side of that telephone pole, right? All these cables are adding weight to that. So it's probably going to pull that telephone pole over, right? So what they do is they create some stabilization for that telephone pole. So they pull it this way. That right there is your guy wire. Okay. This question it talks about a radio tower. If you've ever gone out to Elida Road and look at Time Warner or Spectrum now or whatever, they got those huge towers, right? And there's a bunch of wires coming off to the ground. Those are all guy wires, and they're just stabilizing that huge tower so that when it's windy, it doesn't fall over. Okay. So here it says we've got these guy wires on this tower. So there's my guy wire, and it creates an angle of elevation with the ground of 65 degrees. So there's 65 degrees. Okay. I think that this one should probably say use an angle of elevation. It should use angle of inclination because your line of sight, if you're right here, your line of sight is following a physical object, right? It's following that wire. Just the way I interpret that definition. But it says that that's 175 feet. They want you to find the height of the tower. Can we do that? Okay. So which ratio would you use here? You would use the sine. So you would say sine of 65 is equal to opposite over hypotenuse. Okay. Multiply by 175 and you got your sine. Now there is one more question, and we're going to finish up with this, but it's going to take a little bit of time. So I don't want you packing up. I don't want you leaving because it's going to be on it's potentially going to be on your test. So the question is this here. It says Oscar is in a lighthouse on a cliff. It says he observes two sailboats due east of the lighthouse. Okay. The due east part doesn't really matter. It just means that it's they're both to one side of it. Okay. So the angles of depression to the two boats are 33 degrees and 57 degrees. So find the distance between the two sailboats. Okay. Knowing the top of the lighthouse is at 803 feet from sea level. So just some things I know. I know that this O to C distance here is 803. Okay, so we know that. And we've got two sailboats. Okay, sailboat 1 and sailboat 2. And they're both due east, so they're both over here to the left. If I think about being Oscar, put myself in his position, is that a line of sight to sailboat 1? Is that a line of sight to sailboat 2? Okay. Is this a right angle down here at the base? Yeah. Now, the cliff might kind of jut out or jut back, and it might not be exactly a right angle, but we're going to assume that if he was hovering here and there's actually no cliff, if he fell, he would fall straight down perpendicular to the ground, right? So there is a perpendicular line here. So we got two right triangles. Everybody see the two right triangles? Okay, you've got that right triangle, and you also have that right triangle, correct? Okay. Let's leave that one colored, but what we want to ultimately do is find the distance between the two boats. So what we're interested in, guys, is actually that red distance there. Okay? That's not part of a right triangle, is it? Okay? But do you see that we could take maybe the distance from C to S1, okay? And then take the distance from C to S2. So deal with those two individual right triangles by themselves. And then what could I do with those two values if I call, let's just call this distance here x, and I call that distance y, what could I do with those two distances to find this red distance? Subtract them, right? Take x and remove from it y, and that should give me that red distance. Okay? So let's see if we can go through and do this for this problem. Now, there are some extra things that are provided in this problem that we need to pay attention to, and they're the angles of depression. It says you have Oscar in the lighthouse, and he is looking at sailboat 1 and sailboat 2. So we need a horizontal placed in here so that we can determine our angles of depression. If I look like okay, if I look at that, it says one angle is 33 and one angle is 57. Would you agree that that is an angle of depression from Oscar to one of the sailboats? Because that's a horizontal and a line of sight, right? Is that another one? Can you tell me which one's 33 and which one's 57? Because those are, one's smaller and one's bigger, right? Okay. So this one here, the smaller one's got to be 33, correct? And that's the line of sight going to the sailboat, correct? So could I say that that is also 33? So that angle of depression is 33. So is that angle of elevation. If this angle of depression is 57, what's that? 57. Okay? Now, here's the question. I'm going to clean things up a little bit. I'll get rid of that line. Let's get rid of that triangle first. Could you find, I think we called this x initially. Can you find x out of that right triangle? Do you have the opposite side? Is x the adjacent side? So can I say the tangent of 33 is equal to 803 over x? Does that make sense, everybody? Solving for x, then, it gives me 803 divided by tangent of 33. That's going to give me that distance from S1 to the cliff. So that's one part of the question. Can I then deal with just that right triangle? Still got 57. Is this still opposite? Let's refer to that distance as y. Could I say the tangent of 57 is equal to 803 over y? It's going to give me y is equal to 803 divided by tangent of 57. Okay? So that gives me those two values of x being the whole thing, y being this little portion. What am I going to do with these two numbers? I'm going to subtract them. Which one's bigger? X. Okay? So when I do subtract these, let's see here. Oh, I think last class I had it already all set up. If we get into Desmos, make sure you're in degree mode. Okay, so we're going to go 803 divided by tangent of 33 minus then 803 divided by tangent of 57. And there's my angle measurement. Or sorry, there's my distance. Sorry. That's the distance between at sailboat 1 and sailboat 2. Okay. If you flip-flop those numbers for some reason, you would have negative 715. And just know that distance has to be positive, so take the absolute value. Okay? Your homework this evening is going to be, it's on my website. It's section 8.4. It's this bottom worksheet right there. It's the bottom one. It's the easier of the two worksheets. If you click on it, it looks like this. Okay? And I only want you to do 9 through 22. 9 through 22. Okay? Some of those questions already got the pictures drawn for you. About half of them you got to draw a picture. Okay? So do those. That's the bottom worksheet on section 8.4. All right? Have a great rest of the day, and thank you for staying over a little bit today. Thank you.